Hello everyone, my name is Emre Uncan. I am studying at Bilkent University. Today I will present you the project of my EEE419 Power Electronics course. The aim of the project is to build a high-efficiency isolated DC-DC flyback converter using MC34063. There are three constraints targeted at the end of the project. The first one is DC output voltage accuracy should be better than ±5%. The second one is the peak-to-peak ripple at the output voltage should be less than 300 mV, and the last constraint is the output power should be as large as possible. The project will be completed in 4 parts. Part 1, converter design, inductor design, transformer fabrication and transformer measurement. For part 2, we need to do PCB design. Part 3, converter fabrication and measurement. For last part, 3-minute video presentation of our project. For the project, input and output voltage values were assigned to each student. As you can see, my goal is to get 24 volts at the output from the 8 volt input. For the first part of the project, I first created the circuit using LT-SPICE with the schematic provided in documents. After that, I determined the necessary component values by following the suggested design procedure. This is the LT-SPICE circuit of the flyback converter I obtained as a result of all these stages. After the circuit is simulated, there are 3 LT-SPICE graphs we are asked to provide. The first one is the output voltage startup transient of the converter. The other one is the zoom-in version of the output voltage for one ripple period, and finally the switch voltage, because the switch voltage is a good indicator of good design. These graphs were compared with the examples given in the report, and it was checked that the obtained values met the constraints. In the rest of part 1, the inductor was wounded. First, the inductance and serial resistance values of the primary side were measured. These measurements were then repeated for the secondary side. Finally, the coupling coefficient between the primary and secondary was calculated. For the second part of the project, firstly, the LT-SPICE circuit was transferred to the DIT trace by using the instructions in Moodle. Then, the PCB design was made using DIT trace again. For part 3, components on the manufactured PCB were mounted and soldered. When it came to the result section, first the input voltage and current were measured using the power supply. For output voltage, it was measured as a 24 volt using a DC multimeter. Afterwards, the switch voltage was measured and checked using an oscilloscope. Output ripple voltage was measured as 80 mV. Finally, turn-on transient was measured as 50 milliseconds. Using the measurements, input and output power values were calculated and the efficiency was found as 70%. For part 4, this video was created, so the project was completed successfully.